problem with like yes, please.
What if it's not as clean as like 45 degrees? Because that's like a whole number of 2 and 4. What if it was like 50 degrees?
Okay, so let's look at that. Very good question. Okay, so let's say theta equals 50 degrees. I know that 1 degree is the same with,
Pi over 180.
that's it. So then all I have to do is multiply this by pi over 180, and I will get the translation. I was going to do that anyway, so this is really helping. So then all I have to do is multiply 50 by pi and divide by 180. And this is, as I expected, 80.87. As I expected, less than 1 radian. It's 50 degrees. 1 radian is 57. Once you set 50 degrees, you have to expect less than 1 radian. If you had said 57, I would have said immediately 1 radian.
Okay.
Good. Very good. Find the radius of each circle if the area of the sector is 12. Please choose 62, part A, or part B. Part A or part B? Okay, very good. So find the radius of each circle if the area of the sector is 12. So the area is 12. And here is part A, in which we are given this angle as being 0.7 radians. There is no need to write 0.7 radians. 0.7 would have been enough, but that's fine. So we are asked to find the radius of the circle. I write the formula A equals 1/2 r squared theta. I replace A by, very good, then I have 1/2, then I have r squared. This is already in radians, so I multiply by 0.7. How do I get r? What do I have to do? First, I multiply both sides by 2 to get rid of fractions. So I have 24 equals 0.7 r squared. And then r squared equals 24 over 0.7, and I will not bother with it. I will just take the square root from both sides. I normally write plus or minus. However, what will you say about this case? Exactly. It can only be positive. So then r equals, I take the square root of 24 divided by 0.7, and I get 5.855. They did not give us a measurement unit, so that's it. In the other case, you will have to change degrees into radians. So in the other case, we will have still 12, but this time we have 1/2 r squared, and we have 150 degrees. That's the other situation in which the angle is given as 150 degrees. So I have to multiply by pi over 180. Those two formulas work only with theta in radians. So here what I'm going to do is, one option would be to get rid of all this. I don't like to use decimal numbers and put it in the calculator like that. So I will multiply both sides by 360. So 112 times 360. Then I will divide by pi times 150. Right? So this multiply both sides by 360, and I have to divide by these. I will not perform any calculations. I will just directly put in the calculator once, not step by step. So the square root, you know me, I have to put parentheses. So 12 times 360, and divide by pi, and further divide. Be very careful how you do it here, or you put enough parentheses. Further divided by 150. So the answer is 3.03. Yes. Any questions? Any questions? These two are in the denominator, so when I multiply 360, I have to multiply. So it goes up here. These two are multiplied by r squared. They will have to go to the denominator. So I get 3.03 as the radius. Any questions? Any questions?
I guess my question is,
Yes.
why not the conversion of the degrees and radians?
Say it again.
Okay, so you're saying not to do the multiplication of the 150 converted to radians?
Yes, and you will introduce error.
Yeah, right.
Yes, that's why I did the calculation once at the very end, and it's done. Okay, so let's look at a right triangle. This is the 90-degree angle. This is angle alpha. Can anyone tell us what will this be? If this is 90 degrees and this is alpha, what will the measure of this angle be?
Alpha.
90 plus alpha.
But minus.
Yeah.
Right. If this is 90, this has to be 90.
Or yeah.
So then the measure of this angle must be
90 plus.
It's the same as the other.
90 minus alpha is 90. 90 plus 90 is 180. Right? So if this is alpha, this is 90 minus alpha. Agreed?
Yes.
Or, another way, pi over 2 minus alpha. Yeah, we have to use both. We have to use both, and we have to try to get used to pi. To radians, I meant. Good. So I'm going to give some letters here. I'm going to say this is A, and this is B, and this is C. So the measure of this leg is A, the measure of this leg is B, and the measure of the hypotenuse is C. We have 6 trig functions, and their inverses, 6 more. So first one is sine, S-I-N, alpha. Second one is cosine, C-O-S. Tangent, T-A-N. Tangent does not mean a line that is touching a curve. This is the function called tangent. Okay? Cotangent. Secant. This is not a line that crosses a graph in 2 points. It happens that we use the same word. But this is the function called secant. And cosecant. CSC. We have to look at the right triangle and identify what each and every one means. Okay. The definition for sine alpha is the opposite leg over the hypotenuse. So it's A over C. Opposite leg over the hypotenuse. Cosine alpha is the adjacent leg of alpha. Adjacent leg, not opposite leg. Adjacent leg over the hypotenuse. Tangent alpha, by definition, is sine alpha over cosine alpha. I copy sine alpha, A over C, over B over C, and after I simplify, what do I get? Very good. Cotangent. By definition is cosine alpha over sine alpha, which is the reverse of tangent, right? Okay, so this is nothing else but 1 over tangent alpha. And what 1 over tangent alpha equal to then? That's it. So I did not show tangent and cotangent in the right triangle. Let's do that now. So tangent alpha, by definition, very important, it's the opposite leg over the adjacent leg. The opposite leg, the measure of the opposite leg over the measure of the adjacent leg. What is cotangent? The reverse. Is the adjacent leg. So cotangent alpha, cotangent doesn't exist. Cotangent alpha exists.
Right.
Like I cannot say f. I have to say f of x equals, right? It's a function. Good. So cotangent is the adjacent over the hypotenuse. Adjacent over the hypotenuse. So if I want to determine cotangent 30 degrees, I will create the ratio b over a, and I'll give you the answer. Okay. Secant. I ran out of room, of course. I always do. Secant alpha is 1 over cosine. So how do I remember this? If the function of these two, the last two, starts with s, is 1 over c. Now if I ask you, keeping that in mind, if it starts with a c, then it will be 1 over, which is sine. Exactly. So secant alpha is 1 over cosine, and cosecant alpha is 1 over sine. So if you want to go back to the right triangle, secant is c over b. It's the reverse of cosine. And cosecant alpha will be the reverse of sine, which is c over a. Now, if you simply remember these three at first, till you get used to the other three, you're in good shape. Because I know that cotangent is 1 over tangent. And because I know secant is 1 over cosine. And I know that cosecant is 1 over sine. So these are the, I wouldn't say core ones or the most important. I wouldn't go that far. But these will give me everything else. Okay. Let's go back to, of course, the unit circle. I'm going to create an angle in the standard position with a terminal side in the first quadrant. An angle in the standard position with a terminal side in the first quadrant. Okay? And this is angle alpha. And this is, I'm back to the unit circle. Although it doesn't matter. Okay, I'm going to form a right triangle, drawing the perpendicular to the x-axis from this point, and this is my right triangle. I am going to denote this piece by, what do you think? Yes, but I'm going to call it x because it's on the x-axis. But you're right. Nothing wrong there. And I'm going to call this piece, of course. And now I'm going to ask you to give me the coordinates of this point. We're going to call this point P. It doesn't matter. I would like to get the coordinates of P. Basically, it's nothing to think about, though. What will the coordinates of P be? Of course. Of course. Right? That's how we created point P. Perfect. Now, this is 1. This is a unit circle. And now I'm going to kindly ask you to state the Pythagorean theorem in this triangle. And I will write it down.
X squared plus y squared.
Do you all agree with this? Perfect. Now I would like you to tell me what to write for sine alpha. And of course, I'm going to ask you the same thing for cosine alpha. Sine alpha is?
X over 1.
That's sine is the opposite. So alpha is here. That's the angle. Yes, it's the opposite leg over the hypotenuse.
So we're using that, the angle next to it.
This is the central angle in the standard position. This is angle alpha. Standard position, angle alpha. Can anyone give us cosine? Perfect. So can I say now that y is sine alpha because y over 1 is y? Can I say that x is the same with cosine alpha because x over 1 is x? So now I'm coming back to my unit circle, and I would like you to identify the ordered pair called P in a different way. Based on what we just did, what will you write? Thank you. That's it. So what is the point I'm making with all this? I'm saying the following. Any point on the circle, will have, based on its position, 2 coordinates, like any point in the coordinate system, right? And the first one will always be, always, because cosine is measured on the, and the second coordinate will always be sine, because sine is measured on the, and now this is the first and the most important trig identity. Tell me how to write this differently. Yes, sine squared alpha. Yes. But there is a sign in there, right? Sine squared alpha plus cosine squared alpha equals 1. That's always the case for the same angle. The most important trig identity, the Pythagorean trig identity. So sine squared 90 degrees plus cosine squared 90 degrees, how much will that be? Sine squared 90 degrees plus cosine squared 90 degrees. 1. Sine squared 30 degrees plus cosine squared 30 degrees. Okay? It's always the case. Any questions? Any questions? This is super important. From here, we're going to, yes? Say it again, Paul. You said something, but I didn't catch it.
Yeah, just trying to relate the two triangles. But
Any questions?
Yeah, so just for review, so sine of alpha
Yes?
is the opposite over
Yes.
alpha.
So alpha is a central angle because it's in standard position. The opposite was denoted by y.
Yeah.
It's measured on the y-axis. And the hypotenuse is 1. So sine alpha is the opposite over 1.
Okay, so it's like whatever angle they get, it's the opposite of that.
The opposite, yes, but if this is
Whatever
not the
central angle,
but if it's not the unit circle, then sine alpha will be this measure over this measure. Cosine alpha will be the adjacent over this measure. In this case, I chose the unit circle. But we can look at an example with not one. Regardless, this relationship will always be true. Sine squared of an angle plus cosine squared of the same angle will always equal 1. We can go back to the regular triangle we had here, and a squared over c squared plus b squared over c squared equals a squared plus b squared over c squared. But the Pythagorean theorem says that c squared equals a squared plus b squared. So this is 1. Because the top is c squared. And c squared over c squared is 1. This happens in any triangle. Yes, Paul, you had something? Did you find your question or?
no, I'm fine.
Okay, very good. Reference angle. So we had a lot of definitions so far, or names, right? We said the standard position, then we said positive angle and negative angle. We said coterminal angles, right? I mentioned standard position, and now we're talking about reference angle. This is a key idea. Okay. So let's look at the unit circle, and I will graph an angle in the standard position with the terminal side in the first quadrant. So here's the angle, alpha. The definition for the reference angle is the acute meaning less than 90 degrees. The acute angle formed between the x-axis and the terminal side of an angle in standard position, of any angle in standard position. Okay, let's read this again. What is the reference angle? The reference angle is the acute angle formed between the x-axis and the terminal side of any angle in standard position. Okay, so is this an angle in standard position? What will be the reference angle of alpha formed between the x-axis and its terminal side? Itself. The reference angle is itself. the acute angle formed between the terminal side of the angle and the x-axis.
So will this always be true?
For an angle in the first quadrant, always. With the terminal side in the first quadrant, always. Here is an angle in standard position, alpha, with a terminal side in the second quadrant. Where is its reference angle? The acute angle formed between the terminal side and the x-axis. This is the RA. For an angle in the third quadrant, with a terminal side in the third quadrant, this is now angle alpha. Where is its reference angle? Between the x-axis and its terminal side, the acute angle. This is the reference angle. And the last one. Any questions? And the last one. Let's say an angle with the terminal side in the fourth quadrant. Standard position, of course. This is angle alpha. Where is its reference angle? Between the x-axis, the acute angle between the x-axis and the terminal side. This is the reference angle. No matter what, the reference angle will always be a positive angle, even if the angle itself is going around the circle in a different direction, counterclockwise. The reference angle is always a positive angle. The question now is, why do we even talk about the reference angle? Well, let's look at this one. Okay, so this is in the third quadrant. Let's suppose alpha is, so this is 180. I'm going to add 30 degrees. Alpha equals 210 degrees. Is this an angle with the terminal side in the third quadrant? What is its reference angle then?
The x-axis.
I already told you how I got it. So what is the reference angle? How did I get to 10?
Oh,
Okay, 30.
Exactly. So the reference angle must be 30 degrees, correct? If the angle is 210, the reference angle must be 30 degrees. Agreed? Okay, perfect. So now I'm going to ask you this, and you should be very upset,
Wait, how'd you get that reference angle, sir?
because I created an angle that I said it was 210. And I know that this is 180. So the reference angle must be 30,
Okay.
right? Because this is 180.
Okay.
That's okay.
I thought we were-
Now,
I thought you were on the fourth quadrant.
no, I'm
Okay.
still here. Sorry about that. So I'm going to ask you sine 210 degrees. What will you say? Yeah, you should say, you lost your mind.
Yeah.
Does 210 fit in a right triangle?
No.
No. Where will I fit 210 here? Right. So, how come that I can still determine sine 210? The answer is because sine is a cyclical, periodical function. And I can determine sine of any angle you want on the planet. From negative infinity to positive infinity. As long as I determine what?
The reference.
That's it. If I don't have the reference angle, yes, I can use the calculator, computers, whatever. But if I don't have the reference angle, I don't know. I don't even know what sine sine will have.
So, I mean, I guess you're,
So sine 210 degrees, don't forget what you want to say, will equal, I'm going to put a question mark here because there is something in there that I have to explain. Sine 30 degrees. For this angle alpha, even if it ends, has a terminal side in the third quadrant, this piece will be his sine. And this piece will be from here till here, will be its cosine. So the reason I put a question mark here is this. One more time, we know that sine is measured on the x-axis or y-axis. I'm going to ask you that several times until we are right. Since the angle ends in the third quadrant, and this is the piece that represents sine. What sign will sine have? Positive or negative?
Negative.
Yes. That's the only difference. Because this piece is under the x-axis. Therefore, sine will be negative. At any point in time, you can always check. So put in the calculator, make sure it go to the mode first. Every time you punch in the calculator degrees, you have to be in degree. Every time you punch in radians, you have to be in radians. Since I'm checking now degrees, so I'll change it to degrees. And then I get out of there. So I want to determine sine, and I put parentheses, 120 degrees. And I'll see what it is. Did I change it? I changed it.
Negative.
Oh, so I put 120. That's why I said, what is this? I put the wrong number. Sorry. Sorry. 210. Okay, enter. And then I put minus sine in parentheses 30 degrees. And the number should be?
0.
Exactly. Exactly. They have to be the same.
Okay, I know, I thought you were subtracting that from sine.
No. No, I put equal. Yeah.
But if you did subtract it,
Yes. So sine 210 is the same with negative sine 30. This is the importance of the reference angle. Huge. Okay, let's look at another example. Let's say I want to find all trig functions of the angle alpha (3 pi over 4). First of all, you should say, wait a minute. I don't even know what 3 pi over 4 is. And where do I graph it? I do. Because we already discussed what pi over 4 is. What is pi over 4?
45.
Right. 45, 45, 45. 3 or 45. I don't have to think. I know exactly where it is. 1, 2, 3. It's right here. 3 pi over 4 is this angle. What is its reference angle? It's the fourth one, till 180, right? So what is the reference angle? 5 over 4, correct? Correct? Okay. So now I want to find sine 3 pi over 4, then cosine 3 pi over 4, and then I'll come back to the rest. I draw, or I just imagine, the right triangle. this piece represents what for our angle alpha?
The opposite.
What does it represent? For sure.
Represents the opposite.
We already established, but we need time. Correct. It's the second coordinate of that point. Okay, very good. So this piece will be sine 3 pi over 4, which will equal, is it positive or negative? Right, which will equal sine pi over 4. Right? Sine 3 pi over 4 will equal the positive, you don't have to, I'm re-emphasizing, sine pi over 4. Good. Now let's look at cosine. This height is positive,
Negative that positive.
so then sine 3 pi over 4 must equal sine pi over 4, because that's the reference angle, pi over 4. I cannot put 3 pi over. I cannot put 3 pi over 4 in a prime.
So the sine of the angle
It's
equals the positive or negative depending on the force.
of the sine or cosine, whatever I'm determining, of the reference angle. The reference angle is the key.
That's your percent. Okay.
Yeah. Now let's look at cosine. Cosine is this piece from here till here. But is it positive or negative? And where do I measure cosine?
Cosine is negative.
Yes, because I measured on the x-axis. So this piece will be cosine of 3 pi over 4, which will be
Negative
exactly awesome.
cosine 5.
That's it. That's it. Before we write these numbers in, I want to get to a right triangle with an angle of 45 degrees. What can you say about a right triangle with an angle of pi over 4 and here pi over 2? What will this be? Correct. Very good. So what do we know about the triangle, which is a right triangle in this case, and with two angles that are equal?
Cosine and sine.
They will be the same, correct. But how is it called? If these two are the same, these two sides have to be the same. So it's called isosceles right triangle. Okay. Say it again. Yes, you're right. The hypotenuse is 1 because we are still in the unit circle. I'm going to call this x, but I have to call this x as well because they have the same measure. Can you please give me the Pythagorean theorem in an isosceles right triangle, of course, with x and x the legs, and the hypotenuse of 1, and I will write it here.
X squared plus x squared
Awesome.
equals 1.
Of course, and I want to solve for x. So it's 2x squared equals 1. What do I do first?
Divided by 2.
Awesome. And now, good. Since it's a length, I'm going to choose only the positive. The square root of 1 is 1, and the square root of 2 is the square root of 2, but I have to rationalize. So this is 1 over the square root of 2, but it changes into the square root of 2 over 2. So then this piece is how much? Right. It's going to be negative because it's on the left-hand side. And how much is this piece? Right. So the answer here is the square root of 2 over 2. And the answer here is? Okay. I have sine and cosine. Now please tell me what to do in order to find tangent 3 pi over 4. And no I don't need to go back to anything.
It's,
I have sine and cosine. And I know the tangent is sine and cosine. They are the same, it's just the sign is different. So what is the answer? Cotangent 3 pi over 4. Cotangent is 1 over tangent. So what do I get? Negative 1. Secant 3 pi over 4. Secant is 1 over cosine. No. So cosine is negative the square root of 2 over 2 if you want, or this. Okay, now this is easier to flip than this. So if I flip this, so I have 1 over cosine 3 pi over 4, which is this, but I would like to use this. So I can flip it, negative the square root of 2. And cosecant 3 pi over 4 is 1 over sine 3 pi over 4, and I have sine 3 pi over 4, but I prefer this one. So I can flip it, and I get the square root of 2. That's how I determine, once I have sine and cosine, I have everything else. I don't have to go back to the circle. I don't have to go back to the triangle. Once I determine the basic ones, then the rest will follow. Because we have to remember that tangent is sine over cosine, cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine. Any questions? Any questions? Say it again. Paul, you wanted to flip this one instead of that? Is that what you're looking at? Because if you flip this, then you have to rationalize again and simplify.
This one was a special case where I guess the reference angle was the same as the other angle.
Oh, it doesn't matter. We are limited. We are limited to 3 special cases or the corners.
Well,
Nothing else we can do by hand.
what I'm saying is, how would we do it if we wanted a both angles more than 45 or 5
With 30 degrees. Whatever the reference angle is. But we are limited by hand to 3 angles. 30, 45, and 60. That's it. If it's 185 degrees, we can't do it by hand. We have to use the calculator. Because the reference angle would be 5 degrees. I have no idea what sine 5 degrees is. No one does. We have to use the calculator. Good. I want to go back to the most important relationship. And I'm going to ask you to tell me what happens if we divide this. It's also called a trig identity. Trig identity. If we divide both sides by sine squared. Please tell me what to write. Dictate. And I will write it.